No. Yes. So if you look here, we have cosine of x over 2. And we have the identity with cosine of x over 2 equals this. So I'm going to take this and plug it in right there instead of the cosine of x over 2. So I get plus or minus the square root of 1 plus the cosine of x over 2 minus the sine of x equals 0. And this one was rough on the test. This was, very few people got this. Okay? So this is probably a really good one for us to go over. Next step. This goes back to college algebra, people. If you have a square root, yeah, Matt, you're getting a little help here ahead of time. Okay? If you have a square root, you always, it's a bad plan if that was it. Okay, anyway, back to the square root. If you have a square root and you want to get rid of it, the first thing you do is get rid of everything else so it's a square root all by itself. So now we have the square root of 1 plus cosine x over 2 equals sine x. Okay? Now that the square root's by itself, I can square both sides. That means the square root and the squared cancel. The plus and minus is all going to cancel out because they'll both be positive. So we have 1 plus cosine x over 2 equals sine squared x. Whenever you see a squared in the problem, you should be probably 99 times out of 100, you should be thinking double bubble, which means get everything to one side. The first thing I need to do, though, is get that 2 out of the denominator, so I'm going to multiply both sides by 2. So then the 2's cancel, and I get 1 plus the cosine of x equals 2 sine squared x. And now I'll get everything to one side. So I have 0 equals 2 sine squared x minus cosine x minus 1. But that's still a problem for us, because why?
There's two different.
We've got sine squared and then a cosine here. They got to be the same thing, right? So then we're going to use the identity for sine squared. Sine squared equals 1 minus cosine squared from the Pythagorean identities. So we're going to replace sine squared with 1 minus cosine squared. And at this point, I want to say, and then you just do your math, but I saw some bad math on the test, so let's go through this. So I have a subtraction in here, right? Right in here I have a subtraction. Mm-hmm. So I need to take the 2 and multiply it through. So we got 2 times 1 is 2, minus 2 times cosine squared, minus cosine, minus 1. And then I have 2 and I have a minus 1. Those can go together. Okay, I know I've talked about this before. I really don't like having my cosine squared being negative. So I'm going to multiply everything by a negative so that it's a positive. That way when I double bubble, it's easier to think about. Double bubble. Set each one equal to 0. So cosine of x equals 1/2. And over here, cosine of x equals -1. And then it's just a matter of the unit circle and figuring out when this happens. So cosine is 1/2, that's the x value, at pi over 3 and 5 pi over 3. and then cosine is -1 right here at pi. So in this, you're given the cosecant of x equals root 41 over 5, and you're supposed to find cotangent and cosine using identities only. So no triangles here. And one of the things I did on the test, and I will continue to do, is if I tell you to use identities, I better see some identities on your paper, right? Don't just give me an answer, because I have no idea where it came from. I need proof that you used identities to correct this. So, is there an identity with cosecant and cotangent? Okay, and what is that one? 1 plus cotangent squared equals cosecant squared. So that works out great for us because remember our goal here is we find an identity that has what we know, and then the only thing that we don't know is what we're trying to find. Okay, we can't have too many trig functions in here that we have too many variables. So we're going to replace cosecant with root 41 over 5. So now we got 1 plus cotangent squared equals, and then we have root 41 over 5, but we have to square that since cosecant's being squared. Okay, so then that gives me, when I square the root 41, I just get 41. When I square the 5, I get 25. And then I have to get cotangent squared by itself, so I'll subtract 1. And I'll need a common denominator, so we'll do 25 over 25. So we have cotangent squared equals 16 over 25. And then that's cotangent squared, so I'm going to have to square root both sides. So then cotangent equals 4 over 5. Now, did they tell you a quadrant or anything like that, or are we not worried about it?
We're not worried.
Okay. Now that's cotangent, so cotangent's done. Now I have to do cosine. And so I'm pretty sure there's nothing with cosecant and cosine. However, if cosecant of x is root 41 over 5, that means sine of x is 5 over root 41, right? Now don't worry about rationalizing at the beginning of a problem. Only rationalize at the very end. If you rationalize at the beginning, all of a sudden you've got big numbers that you got to work with. Instead, now that I know sine is 5 over root 41, I can do what? Huh?
No.
Does that help me find cosine?
Yeah.
Yeah.
Because I have another Pythagorean identity, right? Sine squared plus cosine squared equals 1. And so sine is 5 over root 41 squared plus cosine squared equals 1. If I square that, I get 25 over 41.
I thought all these points taken off because I didn't do what we wanted to.
Yep.
I'm dumb, not you.
Subtract, no, I know.
Well, the way I said it, it sounded like I was being mean.
I wasn't taking it as mean, and I didn't mind to be mean either. Okay, so subtracting, we have to take 1, subtract 25 over 41, so let's get 41 over 41, right? Common denominator. 41 minus 25 is 16. Square root both sides. So the cosine of x equals, the square root of 16 is 4, and then the square root of 41, at which time now we need to rationalize, right? So we'll multiply top and bottom by the square root of 41. So your answer is 4 root 41 over 41.
I did it a weird way.
Okay.
I did 4/5 equals cosine over.
So we'll do a sine inverse of root 2 over 2. So what you're doing is you're looking at the unit circle, okay? Sine is restricted at the first and the fourth. Remember, this is sine and tangent are restricted here. Cosine is restricted in the first and the second. Now, we're looking at, if we set this equal to x, if we rewrote it into scientific, if we wrote it back into normal, it'd be that the sine of x equals root 2 over 2. So we're just trying to figure out what angle gives us that. Okay? Now, sine is the y value, so we're looking at y values, and root 2 over 2 happens at the 45s. Right? Because x is root 2 over 2, and y is root 2 over 2. So we have to pick which one is it. Is it going to be this in the first quadrant or is it going to be in the fourth quadrant? And sine is positive here, right? That's a positive at 2 over 2. So we're going for the first quadrant. Our answer is going to be pi over 4 or 45 degrees. Now don't forget though, if you had picked this quadrant right here, it would not be 5 pi over 4, or it wouldn't be 7 pi over 4. It would be negative pi over 4. Because remember, this is going backwards.
So you couldn't put 45 degrees, you want it pi over 4?
Yeah, I would have taken degrees. Yep. Okay. Did that answer your question, Emily?
Yeah, the ones that are like bigger, I guess.
Give me another one then.
Arc, cosine, and negative 1.
What test is that?
Test 4A.
What Max, do we have different test 4As?
Part 2 or
This is
non-calculator part?
no calculator part.
No, you didn't. You had the same tests.
What's 4?
There is 3 test 4s. There's part A with calculator and with non-calculator. This is the non-calculator.
Found it.
Okay. So, cosine is restricted in the first and second quadrants. Okay? Now, cosine is the x value, and because we have a negative pi 1/2, we're definitely going to be looking in the second quadrant. Okay? Now, cosine is the x value. Now, this is going to be either 30 or 60, right? It's going to be one of those multiples of 30 or 60. And so when we're thinking about cosine, we're thinking of the x value being smaller because it's either root 3 over 2 or 1/2. Now, 1/2 is smaller than root 3 over 2. So cosine is going to be short. Okay, so it's going to be this one right here up at the 60. But the answer to that really is that it is not 60, but 120, right? Or 2 pi over 3.
I must have been in need of those. This phone for reviews.
First thing that I see is that cotangent, I'm going to rewrite that as cosine over sine. Cosine squared over sine squared.
Wait, I have a question. Can you just do that when you don't have squared things?
Can I do what?
Like say that was cotangent minus cosine. Can you just,
Yeah, you can still do a fraction. Yep.
so it doesn't even matter if there's a square. Like even these Pythagorean ones, it doesn't have to be a square. It's going
Oh. So then now that I have a fraction in one, I'm going to have to get a fraction in the other and get a common denominator. So I'll have to multiply by sine squared, top and bottom. So now I have cosine squared minus cosine squared sine squared. All over the same denominator of sine squared. Now a lot of you kind of got stuck around this point. Like some of you actually went through to this point and then kind of got stuck. So what I'm looking at is I have a subtraction here, and they both have a cosine squared in it. So I'm going to factor out a cosine squared. So I have cosine squared. And then, some of you lately have been forgetting about this guy. If I take a cosine squared out of here, I'm left with a 1. It doesn't go away completely. I'm left with a 1. And then I take a cosine squared out of there, so I have sine squared. All over sine squared.
Okay, so you know how there's a 1 there. Why isn't there a 1 on the other cosine square?
I took that cosine out.
Oh.
Because it's there, you just don't put one sign to it.
Oh.
Like that second cosine, I think is what you're asking for?
I took cosine out of here and here, and that's this one right here. Okay?
But she was wondering
So
why there's not a 1 in front of sign.
Yeah.
oh, you
Because you don't have to.
you have a sign, so you don't need a 1 there.
Okay.
Okay, moving on. 1 minus sine squared, that's an identity, isn't it? Right? Isn't that equal to cosine squared? If I shifted around my identities. So then I still have cosine squared x, And then I have another cosine squared x over sine squared x. Now let's pay attention to what we're trying to get. I'm trying to get cotangent squared times cosine squared. I have a cosine squared here. So now I'm looking for a cotangent squared. Now here I have cosine squared over sine squared. That is cotangent squared. So cotangent squared times cosine squared.
Oh. I just don't know, like,
No, I'm not.
what number is this? I'm not
Oh, I just didn't write that. I just thought of it.
7.
Okay, so here's what I'm going to do.
Is this class over here?
Stop it. This is it. Stop being mean to my class. Okay, so I need, in this one, I need my trig identities. So if I subtract 1 here from both sides, then I have that tangent squared equals secant squared minus 1. Which means I can replace this top secant squared alpha minus 1 with tangent squared. And likewise, if I subtract 1, I'll have cotangent squared equals cosecant squared minus 1. So I can replace cosecant squared minus 1 with cotangent squared. Now I notice a lot of you actually struggled at this point. This was supposed to be a pretty easy one, but a lot of you struggled at this point. Okay? I have a cotangent squared on the bottom, right?
Yeah, so it's
Do you guys remember this identity where it says 1 over cotangent equals tangent, right?
so you move it up because it's tangent times tangent.
Yeah. So 1 over cotangent squared is going to equal tangent squared.
I
Okay, this
remember
is
one.
kind of Megan's question earlier, right? So tangent squared, by the way, is on the top. So if I want to take 1 over cotangent squared and replace it, I'm going to replace it with tangent squared on the top. Does that make sense? Some of you took cotangent and replaced it with tangent, on the bottom. But that doesn't make sense that cotangent and tangent are the exact same thing, right? Okay, so then tangent squared times tangent squared is tangent to the 4th. Amplitude is 3 because this number right here is 3.
And it doesn't matter negative or positive, right? It's just
For amplitude, yeah, it's just when we actually graph it, we'll pay attention to the negative.
okay.
Then we have the period is going to be 2 pi divided by b, and b is this number 4. So the period is really pi over 2.
Yep.
The width of my quarters is going to be pi over 2 divided by 4, aka pi over 2 times 1/4. So we get pi over 8.
So can't you just look at that thing in the parentheses and say it's pi
And
over
vertical
8?
shift
No,
is
because that's not always going to be the same.
Oh.
Phase shift,
Oh,
oops.
God.
Phase shift is going to be
No, this
3 pi over 8 to the right, because you have 3 pi over 8 there, and then it's a negative, which means you go to the right, the opposite of what you think you should go.
Yeah, I like these
And
ones.
vertical shift is going to be 2 up.
So when you have to factor out a number, is that when x is a number? Like if it was 3x?
Yeah, I won't do that to you on the test either.
I'm just gonna watch it.
I try to make the final pretty basic. I don't try to throw in those curveballs. Okay, so now let's actually graph. I have a vertical shift of 2 up, and my amplitude is 3, so it's going to be a pretty tall graph. Also, my phase shift is 3 pi over 8 to the right. So I think I'm going to do my axes like that. So then I go 2 up, 1, 2. That's going to be my new axis. I'm deciding that because my vertical shift is 2. My amplitude is 3, so I have to go up 3 from there. 1, 2, 3. That gets me at 5. And then I have to go down 3. 1, 2, 3. That gets me at negative 1. Now this actually isn't all that bad for a phase shift. It looks bad at first, but I have a phase shift of 3 pi over 8, so I'm going to tick off to 3 pi over 8. And then the width of my quarters is what I add every time. So I'm going to add pi over 8, and then add pi over 8, and add pi over 8, and add pi over 8, okay? And so now I have to label each of these. And so as I add pi over 8, I had 3 pi over 8. I add pi over 8. That gets me 4 pi over 8, which reduces to pi over 2. The reason I work it off to the side is I want to keep that 4 pi over 8 so that now I can add another pi over 8, and I get 5 pi over 8. Add another pi over 8, and I get 6 pi over 8, which is 3 pi over 4. Add another pi over 8, and that gets me 7 pi over 8, which doesn't reduce. So now I actually have to graph this, so let me get my red back. Now if I'm graphing sine, sine starts at the axis, so I'm up here at the dotted line at 3 pi over 8, so sine starts at the axis. And then normally it goes back up to the maximum. However, there's a negative on this one, right? There's a negative, so I have to go down to the minimum. And then the axis, and then the maximum, and then the axis.
Aww.